Hello?
Hello, can you hear me?
Yeah, I can hear you, Shabana.
Okay, great.
But I can't start my video. It
Oh,
won't let me do it.
okay. Let me just,
Yeah.
okay, let me just fix that. Okay, yeah, great.
Oh, wait a second. So I have to change the camera here.
Yeah, okay.
Okay. Hi.
Hi, how are you?
Good. How are you, Shabana?
I'm
Nice to see you.
great. Yeah,
Yeah.
same here. So should we start our today's session?
Oh, sure. You're in control. I'm ready.
Okay. So, hello and assalamu alaikum, everyone. I'm Shabana Nisar. I'm a particle physicist and I teach at IBA Karachi. I would like to welcome all of you to today's Zoom session with Professor Subir Sachdev. Professor Subir is a theoretical physicist who is currently working as a Herschel Smith Professor of Physics at Harvard University. He joined Harvard University as a full professor in 2005 and has also served as the chair of the physics department. Prior to joining Harvard, he served as a professor of physics at Yale from 1995 to 2005. He completed his undergrad studies in physics at MIT and his MS and PhD from Harvard University. His work is in condensed matter physics, and his research describes the consequences of quantum entanglement and the macroscopic properties of natural systems. The most impressive aspect of Professor Sachdev's research is that it has exposed remarkable connections between the nature of multi-particle quantum entanglement in certain laboratory materials and the quantum entanglement in black holes. These connections have led to new insights into the entropy and radiation of black holes. His work shows the cross-fertilization of condensed matter physics with string theory, topology, and black holes. He has won many awards and honors, including the Prose Award in 2024, awarded by the Association of American Publishers. He has also won the Dirac Medal twice in 2015 and 2018, and he has written 3 books. So, without any doubt, he is one of the greatest physicists of our time and generation, but also one of the kindest and humblest human beings I have ever come across. So, welcome, Professor Subir, and thank you so much for joining us today. I know you have a very busy schedule, so we truly appreciate your taking the time to be with us. So,
Okay. Well, thank you, Shabana, for that very kind introduction, and salam alaikum to everybody. Uh, I can speak a little bit of Urdu, but I think I'll stick to English. Well, I was quite fluent, but I haven't don't have too much practice, you
Okay,
know.
we can test your Urdu.
ठीक
So,
है कोशिश करूंगा मैं
yeah. So I will check your English at the end, Urdu at the end.
okay
So let me just start with this question. So we have a diverse
okay
group of students today, including college and university students. So it would be
Mhm.
great if you could start by sharing your journey of becoming a physicist. I know that during those times, engineering and medicines were the more accepted professions for men,
Mhm.
and young people were not encouraged to pursue degrees in physics and mathematics. If I remember correctly, you were initially studying to become an electrical engineer. And one day
Yeah.
you were playing with circuits at a college in Delhi, and the next you found yourself studying physics at MIT. So, how did that happen? How did you discover your passion for physics? And who or
Mhm.
what influenced you? And how did your path unfold?
Okay, I have to go back and think to many years ago now. Well, so yeah, like you, everything you said is correct. I went to school mostly in Bangalore, now called Bengaluru in India. And my father was he passed away last year. He was a electrical engineer working for the Indian telephone company in Bangalore. And and following his inspiration, I guess I wanted to become an electrical engineer too. And then I joined Indian Institute of Technology in Delhi, where I still was an electrical engineer. But I started to learn more about physics from the teachers there, my fellow students. I read various books in the library. I particularly remember Feynman's lectures in physics. And I think I even saw, no, those days there were no videos available. Yeah, even in school, I was always very fascinated by physics. And of course, also we also heard about various physicists who had made a real impact from India, Bose and Raman in particular. And in fact, Raman was from mostly in Bangalore, so used to hear about him there. Yeah, but I just found the subject very fascinating. But I think my family, certainly my parents, felt this is not a career. So when I came to MIT after my father moved to the US, I continued in studying electrical engineering. I took some electrical engineering classes. But I also started, since MIT gave a lot of freedom, I started to take physics courses. I took advanced courses in physics right away. I started working in a lab, and I really enjoyed that much more. I think ultimately, if I think I'd stayed in India, I probably wouldn't be a physicist today because the system was very restricted. But once I came to the US, one, it gave me the freedom to pursue what I wanted. So that was very fortunate. And two, I found coming to the US that I was actually very well prepared, much better prepared than all of my classmates at MIT. So it gave me a lot of confidence that, actually, all right, yeah, it may be that once upon a time, education and science in India had fallen way behind the rest of the world. But that was no longer the case. I was able to compete very easily with my students at MIT. In fact, it was harder at IIT in India.
Okay. Oh.
Well, anyway, that's a minor point. But anyway, I certainly, I started to get greater confidence being at MIT that I could pursue this and maybe even have an impact. Since I had the opportunity, I said, okay, let's give it a shot. What's the worst that could happen? Years down the road, maybe I will have to switch back to engineering. Fine, but let's at least give it a shot. And I'm still doing it.
Okay.
Yeah, so that turned out to be good.
So besides Feynman, who was your favorite physicist when you were a child? And how did they influence your interest in physics? And did you read, besides that, any popular science books that sparked your passion for the subject?
Yeah, that's a good. Well, in terms of books, I think I read this book by John Gamma, 1, 2, 3 Infinity. That was more about cosmology and astrophysics, and I think it's a long time ago. That people don't know about that book anymore. I think that was one that I really enjoyed. Yeah, but I don't know. It's mostly, I also was very curious about quantum mechanics, and which I started to learn at IIT a little bit.
So how did you get exposed to quantum mechanics? Like, how did you get exposed to quantum mechanics?
I think I would say from the Feynman lectures, for instance.
Oh, okay.
And then, even when you're studying, well, even in the freshman physics courses, there's a little bit of quantum mechanics, but and also if you're doing electrical engineering, you start to learn about semiconductors and various things, but then they just skip over. Okay, this is something that the physicists explain, and I found that I'm not going to believe. I want to know exactly what's going on rather than just apply some other knowledge.
Engineers are not supposed to know those details, right?
Well, yeah, I just felt okay, I have this one chance, and I should know about how a universe works. And so, okay, I was a bit idealistic in those days, I guess. But anyway, so I think it's mostly, I think many people have a very natural curiosity about the natural world, and I was lucky to have a lot of opportunity to pursue it further at a young age. At a young age, so yeah,
So,
it's a little harder later on to go into. I mean, many people, there are people who do switch from engineering to physics, maybe in the graduate course.
yeah.
Yeah, there are quite a few actually.
It happens all the
Uh,
time. And I have seen many
yeah.
people who really love math and physics, but
Mm-hmm.
because people think that job prospects are not very good if you have a degree in physics or mathematics, especially, I guess, in Pakistan. And same is true in
Mm-hmm.
India as well. So the best people do engineering, although their heart and soul is in physics or mathematics. So I want to ask you this question that I'm really interested in knowing, what do you think? What does it take to succeed in physics? Is it innate talent or uh, perseverance, curiosity, or abstract thinking play a larger role? Uh, why do so few people engage
Mm-hmm.
deeply with physics?
Oh, well, that's a very difficult question. I would say it's a combination of everything.
Mm-hmm.
Uh, but I would say physics is such a broad field. There are so many different directions one can go, and the
Mm-hmm.
talents required in different directions are very, very different. So the key is to, first of all, uh, know yourself and find what is it that excites you? What is it that is your passion? And then focus on that area.
Yeah.
And also, I think important, and this is something I've also read in some of Feynman's saying, is that you have to hold yourself to the highest standards. That is, if something confuses you, then and you say, okay, but I'll accept this and it's good enough for the exam. All right, fine, it's good enough for the exam. But when you want to make progress in physics and really maybe discover something different, you have to question everything. You have to
Yeah.
really understand things deeply and hold yourself to the highest standards. I think um, that's an important lesson. It's difficult, and sometimes that may mean other people are making all kinds of claims around you that you may not believe, and may get an advantage for a while. But in the end, just persevering and pursuing what you believe in, I think is far more important than knowing some very advanced mathematics. I mean, that's something uh, at least I found that you can learn or ask somebody to help you with.
Mm-hmm.
Uh, but it's really deciding, having some global deep understanding and asking the right questions are often the most important things. And
Right.
then once you
And
have the right approach and the right question, you can find somebody to help you.
yeah, and don't you think, like, if you are in theoretical physics, if you have those ideas, you should have the ability to translate those ideas using mathematics, right? Because math is the language of physics at the end of the
Uh,
day. So,
sure, of course, but that doesn't mean you need, the most advanced mathematics that's needed for the latest theorems in number theory, which is what
right.
modern
Mm.
mathematics is completely opaque to even the language they use today. So there's certainly a basic uh, language mathematical knowledge you need, but it's something not beyond, say, sophomore year, second year of college. Multivariable calculus, differential equations, complex variable theory, maybe a little bit of group theory, uh, and these are things I think almost anyone can pick up given enough time, uh, if the right preparation. Yeah, but I mean, it's true in certain aspects of string theory, you need to know some very modern.
Yeah,
Uh,
theoretical particle physicists, right? They like it's something. very
Yeah,
complex mathematics they're using all the time.
but a lot of that mathematics was developed by physicists as they were
Right, exactly,
asking.
exactly.
So taking an advanced mathematical course is not necessarily going to help you in that direction.
Yeah.
Uh, there have been a few occasions in the history of physics where someone, because of the right mathematical training, has been able to make an advance.
Mhm.
I mean, maybe Witten is one such example, but that's not how most things in physics get done. It's not by I mean, even for example, let me take theory of topological insulators these days,
Mhm.
where there was an important breakthrough by Kane and Mallet, and so someone and they or even the Chern-Simons term, for example. I mean, that of course had been discovered in mathematics earlier, but Kane and Mallet, through some physical arguments and simple arguments, came up with this new type of topological insulator, which were very physical. But then later on, there was some very elaborate mathematical justification of it, and it became part of a very sophisticated theory. But the fact remains that the people knowing the mathematics were not the one who discovered this
Yeah,
type of insulator.
yeah, I agree with that. So, okay, we have many students with us today. So, I would like to ask you that could you tell us about the admission criteria for getting into MIT and Harvard? How was it during your time and how it has changed over the years? Yeah, so.
Well, so I don't know much about the undergraduate admissions, if that's what the students, for after high school. In my time, grades and recommendation letters and SAT scores were the main criteria. And I mean, it's still similar today, but I think the weights may have changed a little bit. I think these days, your recommendation letters and extra activities of the classroom somehow seem to play a more important role than they used to in my time, I think.
Mhm.
But I have been involved personally with in the graduate admissions for the PhD program. Yeah, in fact, next month I'll be reading lots of applications.
Okay.
uh, and so I can say I'm more knowledgeable about that.
Uh-huh.
And there, I mean, we are looking for people who are going to succeed in a PhD program. And so we're looking for people who have, uh, uh, you know, well, first of all, have the needed physics background and then have at least a rough idea of what excites them and what they want to do. Having had one research project, not necessarily a publication, but some research project, a thesis project, which you can coherently describe in your essay on what you did, why you did it, and what its implications are. Uh, that can really sway a reader. If somebody has uh, a it's the type of thing. If you use ChatGPT to write it, believe me, we can tell. I think I don't know.
Exactly. You can always tell that. Yeah, that is true.
Although ChatGPT is getting better and better these days, so I don't know.
Yeah.
Uh, but really, yeah. So if it's but ChatGPT will produce something that's
Mhm.
similar to 1,000 other essays that are out there. So that's what will happen. And then when you're reading 200 or 300, you're looking for about 10%.
Uh-huh.
At least at Harvard, that's typically how the numbers go.
Mhm.
Uh, so yeah, so the uh, essay is very important, as are the recommendation letters, and grades. It's okay to get a few B's and C's here and there, but the important physics courses, at least the later ones, if you've done well, that's fine. Uh,
Mhm.
uh, but I would say in degree of the research experience, some research experience, your essay, uh, And the recommendation letters are probably more important than the grades.
Yeah. So,
These days, actually, even I think we do, at some stage, we do a brief Zoom interview also.
oh, okay. You do that.
That's something, I think other universities are starting to do that too. I'm not sure exactly what's happening these days, but there is an interview at some point.
Oh,
Not everybody, but if you
uh-huh.
made the first cut, I think. Yeah.
Okay. Okay. So,
But I say apply and apply to not just to Harvard but many other institutions, because it is a bit of a random thing. I mean, we are trying to make a judgment, and we are human, and we certainly overlook some very good applications. So, and there are many, many good places out there. So find the
yes.
one that excites you most and go there.
Yeah. So you completed your PhD at a very young age. I believe you were hardly 24 when you received your degree. No, I was 26 when I completed my PhD, and many
Yeah.
people will say, oh, that's too young to get a PhD from a university in the USA. Considering the average time to complete a PhD in the USA is around 5 years, whereas in Europe and especially in the UK, it's typically 3. So, could you tell us about your experience and the work you did during your PhD? Just like in simple words, the work you did.
First thing I would say, no, of course, I'll be happy to talk about it. I would say, I'm not sure that's such a good thing to get. I agree with that. I was, it's not a sprint race. Of course, I
Exactly,
was
it's
young.
not. Yeah. What work you have done, the quality
But
of work
later
that
on,
matters.
later on in life, there were other periods where I was slower than other people. So in the end, when I look back, okay, the fact that I finished my PhD at a young age, I could have finished it 2 or 3 years later, and I don't think it would have made any change to my career, or maybe even have improved it. But yes, what was the original question?
So how was your experience and the work you did during your PhD years?
So I was here at Harvard and working with David Nelson, and I was working then on he was interested in statistical mechanics of glasses, and so he was doing some problems in the packing of spheres. So it was purely classical mechanics. H bar was 0 in everything I did in my PhD.
Okay.
And so that's what I worked on with his guidance, and we were actually, because of David's ideas, thinking about how when you pack spheres randomly, they often form little icosahedra. And that's what my thesis was about, was looking for these icosahedral correlations in random packing spheres. Yeah, sounds like a very mundane
That's
problem,
exciting.
but the remarkable thing, but we, missed something really important, which happened in my last year of my PhD, where there was, in fact, the same issue of PRL that my main work was published. The next paper was Sheckman announcing the discovery of quasicrystals.
Oh, okay.
And these quasicrystals are, of course, quasi-periodic arrangements of icosahedra. So we were very close, although I would say David was much closer than me, of having anticipated quasicrystals, but we didn't. We were talking about random packing of icosahedra, whereas quasicrystals were quasi-periodic packing of icosahedra. And so immediately, of course, I started working on quasicrystals, and we had some papers on it. And then after I graduated, I went to Bell Labs and for my postdoc, AT&T Bell Labs, and then I just started working on something entirely different. I switched completely to some problems that are associated with experiments that people were doing there on semiconductors, electrons. For the first time, I was dealing with electrons.
We will talk about that as well. So let me ask you, A bit philosophical question. So we have witnessed a period of remarkable progress in physics during the late 19th and mid 20th century. So that was very exciting time. New theories were emerging and groundbreaking
Mhm.
research discoveries were being made at an unprecedented rate. The contributions of brilliant physicists such as Feynman, Dirac, Einstein, Pauli, Oppenheimer, these all people transformed our understanding of the universe and shaped the course of modern physics. However, in recent decades, the pace of progress seems to have slowed down. While we continue to make strides, many wonder what has led to disappear and deceleration in the field. Do you think this slowdown is due to the increasing complexity of the problems we are trying to solve? Or is there any other underlying factor at play? Could it be that we have reached, some dead end in certain areas, or perhaps the challenges now are more subtle and harder to address? So, what do you think? Do you feel the same
Uh,
way, or no?
I think, yeah, I think you make some very good point. I would agree that there are certainly very special periods in history
Mhm.
where there are some big revolutions. I mean, you could say the Newtonian revolution and the
Yeah.
quantum revolution,
Mm.
or I don't know, you could even go farther back and say the going from Roman numerals to Indian or Arabic numerals was another such
Yeah.
revolution that
Yeah.
completely changed the nature of mathematics. So
Yeah.
there definitely are periods where just many remarkable things happen, and often when you're part of a revolution, you don't realize you're part of it. So are we in such a revolution today? I don't think so, but
Uh-huh.
time will tell, right? It takes a while to realize that everything has changed,
Yeah.
even while you're in the middle of the change, I think.
Yeah. So,
uh, so yeah, I mean, I'm reminded there's this phrase, I guess, Van or Bush or somebody said, science is the endless frontier. I think that is correct. There is a lot that's happening in science, and it will continue to happen. Uh, will it happen at CERN where they're looking at more and more microscopic scales and
yeah, I mean,
uh,
we have been only able to find Higgs, right? That was pretty
right, they found the
disappointing.
Higgs and they're looking for supersymmetry,
Yeah.
and maybe they'll find that. But is that where the next revolution is going to come from? Yeah, I agree. I would say no. Uh, so, uh, but uh, on the other hand, the remarkable things happening now. For example, we now know there's a supermassive black hole at the center of the Milky Way. This was something we didn't know when I started school or college. Well, I don't know exactly when it was fully accepted, but it's relatively recent. Uh, we have, again, we have all these telescopes which are telling us about what's happening right around the Big Bang. And then in my own field, quantum materials and quantum information theory, a lot of remarkable things are happening. And then machine learning is completely changing the nature of computer science now. So there are many revolutions, science broadly speaking, happening. Uh, so I would say physics has a role in all of this. So getting a PhD in physics will prepare you very well to be part of the next revolution. That's what the way I would put it. It may not be doing the physics of yesterday, uh, but it'll give you a broad perspective on how things have happened. And physics, in fact, is central to machine learning revolution, which is
Yeah.
that's as this year's Nobel Prize
Yes.
emphasized.
Yeah.
you
Exactly.
know, and so ideas from physics that are changing neuroscience, machine learning. Ideas from physics are, of course, extremely important for all the work on astrophysics. And then there's, quantum computing, where people are building quantum devices on a bigger scale. I personally don't think they'll really be computers, but they're really teaching us much more about quantum mechanics on a large scale in a way that we didn't know before, and who knows what that will lead to. And again, that's something you can be part of if you started out in physics. So I would say,
Yes, exactly.
uh, yeah, I
So,
think this is also a very exciting time to be alive and to be learning about all these things. And maybe people will look back on this period too and view it with envy, but we don't know.
yeah. So, okay. So my next question is about, now we have social media. We have, we are just one click away from giving our opinion. And
Yeah.
many individuals now discuss scientific matters on platforms like YouTube and social media, and some of them heavily criticize academia and establish research directions. These voices often gain significant attention due to their large reach. How do you think this trend might affect the future of scientific research at universities? For example, string theory is frequently targeted, but physics as a whole, including areas like high energy physics and other branches, seems to be coming under increasing scrutiny. In light of this, do you believe physicists need to engage more in public outreach and increase their presence on social media to counter these criticisms and better communicate the value of their work to society?
Yeah, yes, with the short answer. I think physicists definitely need to, get with the times and not say it's sufficient to publish in some obscure journal that only their friends will read, but may take the
Exactly.
effort to take the effort to reach out to the wider public and especially to young students,
Mhm.
and recognize that an important way to reach the young minds is through social media. So,
Yeah.
the social media, it can be a very useful forum even for professional physicists to discuss the latest uh, paper that's been posted on archive.org and so
Yeah,
on.
that's true.
Uh, and I posted some of my lectures on YouTube, and I think I've many times heard students saying they watched it. So, all right. So, uh, but like any other medium of communications, not everything is reliable, and really it's buyer beware. I mean, every student or person out there has to form their own judgment on to uh, what to accept. And so I would say a firm grounding, which can only come from personal education, is important for everyone in
Yeah,
on what science is about and how does science work, so that
yeah,
you
yeah,
can then use a careful judgment of what's out there in social media.
yeah.
I don't believe in blocking it. I think a free debate is perfectly fine.
Mm-hmm.
And there are many blogs out there of reputable